Assalamu alaikum. My name is Muhammad Mudassir. This is lecture number 3 of digital signal processing, the course of digital signal processing. In this lecture, we would discuss some basic concepts that would help us understand and grasp the digital signal processing more accurately. Now, to moving on, the basic concepts of digital processing are concept of causal system and the concept of non-causal system that we would read in this lecture, and also what are linear systems and how we could define it mathematically. Now, as we move on to the system of that we first call the causal system. Now, whenever we would define a causal system, it would be a system that depends upon the input and the previous value of input. Now, what I mean by this is not that it is uh, some sort of system that would take the previous value of input and would depend upon the previous value of input. Now, if we express it in terms of mathematics, it would look like that: y of n is equal to x of n minus x of n minus 1. Now we can clearly see that n minus 1 is something that is depends upon the previous value of input. N minus 1, a value after the a value previous to the n. It would show that it is a system that depends upon the previous value of input, and you could clearly see that x of n is the value of input. Now if a system looks like that, which has either of these two properties, which either depends upon the value of input or depends upon the previous value of input, it would call a causal system. Now it could be anything like that, i.e. it could also be like 2n minus 1, or it could took any form that is obvious to the mindset. And by showing these examples, it could be clearly understood and grasped that these type of system would be called causal system in terms of digital signal processing, and also in terms of signal processing at large. Now moving on to the next topic that also relates to digital signal processing, that is called non-causal system. In this system, we the non-causal system is defined as something which depends upon the future value of input. I mean, which the function would depend upon the future value of input. Now, if we look at it mathematically, now the function would be y of n is equal to x of n plus 3. In this, we could clearly see that the n plus 3 is some value which depends upon the future, and hence we could say that n plus 3 is the value which depends upon the future, and that is the reason this function would be non-causal in nature. Now, moving on to the next question and the most important aspect of our digital signal processing, that is called linear system. A system is called linear if it satisfies the two properties, homogeneity and additive property. By satisfying these two properties, a system could be declared as linear system. And if we could describe a system as linear, it would help us understand that it could grasp the most important aspects of digital signal processing. By understanding the concept of linear system, not only our system could become very easy, but we could also classify our discussions and our knowledge into more specified knowledge. Now, for moving on to the next topic, how will you discuss homogeneity? That is another important aspect of our lecture. We could describe homogeneity as something when a function x of n when a function x of n goes to a system, it turns out to be the y of n. Now suppose we add another factor alpha or a into the x of n, and the system returns the alpha of time yn, then this system would be called homogeneous system, because it has no impact on the system except that it has multiplied the constant that we have multiplied with the input value. If a constant is multiplied with the input, and the same output in the and same input and the same constant is achieved or received at output, it is called a homogeneous system. Now the second property that is more important in this linear system is called additive property. If a system has two inputs, x of 1 and x2 of n, and it goes to the system and it goes out of the system, and it has y of n and y2 of n, it would be called additive system, an additive property of the system, which would say that x of 1 and x2 of 1 have no impact on each other, yet they are two different functions, that the two inputs that are treated very differently in the system. These two properties define the system as linear function. Now moving on to an example that would properly and more clearly explain this concept. This is called an example of digital signal processing. Now in digital signal processing, you would see like many examples like these, but let us take an example for understanding and grasping the digital signal processing. Y of n is equal to x of n minus 2x minus 1 n minus 1. This is an example that we would understand, is it linear or non-linear. Now, to know that a system is linear or non-linear, it should satisfy two properties: homogeneity and additivity. Now, if we look at the homogeneity, we could say that let us define x1 of n is equal to x1 of n minus 2x1 and minus 1. Now, if I take alpha and multiply with it, it would become like that: alpha 2x x1 minus 1 minus 2 alpha x1 and minus 1. Now, it could be clearly seen that this function, if I took out alpha from this function, it would become y of n, y1 of n. It means that the system is homogeneous. The same has returned an output which has been entered in the input. Now, moving on to the next lecture, next point, and next important factor, which is called the property of additivity. Now, we know that the property of additivity is a property in which we could explain and properly grasp the concept of treating independent functions independently. Now x1 of n is a function which has some value x1 of n and minus 2 x of 1 and minus 1, and x2 of function is a function which has two different values. Now if both of these systems pass out of system, pass into the system, then it would return they would return some values which would look like that: x1 of 1 plus x2 of n minus 2x1 plus 2x1 and plus n minus 1. Now x1 of n and minus 2x1 and minus 1 could is can easily be identified as y1 of n, while x2 of n plus 2x1 and minus 1 could be identified as y2 of n. It means that the system is homogeneous, and hence it could be understand from this example that a system is homogeneous, and hence by following these steps we could measure if a system is homogeneous or not.